friends, this is your scientist Chloe. Today I'm going to do an experiment using the scientific method regarding erosion. Soil erosion is a natural process. Waves, wind, water, and glaciers shape and reshape Earth's surface by gradually eroding the rocks and soil, moving them from one place to another. Rainwater flows through the topsoil downhill into the water basins. Then it could create some beautiful landscapes. Do you remember the La Jolla Cove? That is a perfect example. The big question is, how is erosion affected by the different types of soil and ground cover? Hypothesis. If three types of soil, one is loose with no ground cover, the second detritus with small rocks, and the third one which with rooted grass are exposed to flowing water, then the one with the rooted grass will have the least amount of erosion, as soil is better protected by plant cover and the roots hold the soil in place. While the bare soil will have the most erosion due to the lack of protection provided by the ground cover. Let's do the experiment now. Here are the experiment materials. 3 water gallons, 3 clear plastic cups, scissors, timer, the cell phone is good, small garden shovel, soil, which I already have here, 3 bottles or 16 ounces of 3 cups of water. Step 1. Collect loose soil and detritus, leaves, wood, chips, twigs, etc. and place in separate containers. With assistance from an adult, use a small garden shovel or other sharp tool to cut out a small rectangle patch of grass with roots and soil attached and place in the container. Step 2. With assistance from an adult, use scissors to cut a large rectangle out of the side of each water bottle. Place the bottles on their sides in a container to lift them a few inches off the ground. Let me put the signs now. This is bare soil. This is detritus with leaves, twigs, and small rocks. And this is rooted grass. The first bottle with bare soil, and the second with detritus, and the third with rooted grass. Set your timer now. I will set my timer now. Pour an equal amount of water into the water bottles. That is the amount of time that it used to put the water into this cup, the plastic cup. Erosion observations. 3 samples of soils were placed in different containers, and their ability to mitigate soil erosion was tested by pouring the same amount of water into each sample. It became evident that the grass was the most effective ground cover for minimizing soil erosion. The bare soil yielded a water mix with high turbidity and large particles of soil with small rocks. Since the rocks hampered the impact of the water on the soil and slowed off runoff water, only slit-like substances were eroded and they mixed well with the water. Thus, the sample with the rocks was the second most effective ground cover for minimizing soil erosion. Soil with grass. Amount of water was collected was greater, managed to retain the sediments better by impeding surface runoff and thus yielding a clearer water mix. It dramatically slowed off runoff to water to give it more time to infiltrate the soil. Bottle ground cover. The bare loose soil collected 10 ounces of water, and the time for water to stop flowing out of the bottle was 1 minute and 15 seconds. Lots of sediments. Soil with small rocks, or detritus. The amount of water collected was 15 ounces. And here's my conclusion. Erosion occurs more slowly when soil contains both living plants because plants slow down water as it flows over the land, allowing much of the rain to soak into the ground. The branches and leaves of living plants also soften the fall of raindrops so that they do not hit the ground too hard and break apart the soil. The roots of plants also hold the soil together and make it harder to erode. Detritus can protect the soil beneath it. Similar to the leaves on living trees, the dead leaves on the ground of soil can soften the fall of raindrops so they cannot easily loosen up and carry away the soil. As detritus falls in many layers on top of the soil, it weighs down on the soil and makes it more compact. Bare soil, such as soil found in deforested areas, can be moved much more easily. And that concludes my experiment. This is again your scientist Chloe. Thank you for watching, and bye!